Hello, ladies and gentlemen. Today the objectives that we're going to cover are these three. First, you need to understand acid and base strength depends on its ability to ionize or break apart in solution. You're going to be able to estimate the H plus concentration of a solution, and you're also going to be able to calculate the pH, pOH, H plus concentration, or the OH minus concentration of a solution. So let's get started. First of all, acid strength is defined in two ways. We define acids as either strong acids or weak acids. Now, strong acids are substances that completely dissociate. What that means is when I put them in water, they actually fall apart. So an example of a strong acid is something like HCl. So pretend with me for a second that this is HCl. This is hydrogen, or H plus, and this is Cl minus. Now, how we write it is like this. We write HCl, like they're together. But in fact, in those solutions, because they're strong acids, these substances are actually never connected to each other pretty much. We say they completely dissociate, which means they don't exist like this, they exist like this. Now, weak acids, on the other hand, some of them dissociate, or what we would say maybe ionize. They partially fall apart. So that means some of them are floating around in solution like this, all connected, and some of them are not. That's the main thing to know about strong acids and bases, is that strength of acids and bases depends on how well they ionize or dissociate in solution. Here's an example of dissociation. Now, I don't know if you can see this very well because of this white outline here, but in strong acids, red represents the negative ion. So let's say like Cl minus or chloride. And a proton is represented by this white sphere. So in a strong acid, those white spheres and red spheres are never together. Okay? None of them are connected. But then when you come over here to the weak acid, some of them actually are connected, but some of them are not. That's the difference between strong acids and weak acids. Strong acids, H plus and the anion are never together. In weak acids, some of them are together, and some of them are not. And the amount of them that are together and those that are not are determined by something called acid dissociation constants. In other words, there are numbers that we have assigned to how many of each of these substances are together. Now, you don't need to know these numbers. All that you need to know is that weak acids, they have a number that is associated with how many of their particles are actually together, and if they completely ionize. You'll notice right here, sulfuric acid, right here it says that its number is very large. All that that means is it completely falls apart. All of these other substances do not completely fall apart. Then we're going to talk about base strength. Now, bases, the strength of acids and bases is the same, or the strength of acids is the same thing as the strength of bases. Strong bases completely dissociate, which means if I had a base like, say, sodium hydroxide, NaOH, let's say that this is the Na and this is the OH. In that strong base, these two substances are actually never apart. They're ions floating around in that solution. Okay, that's a strong base. Weak bases partially ionize, which means some of the substances are floating around, not connected, and some of them are connected. Here's an example of that. Strong base, none of them are connected. Notice how the purple represents and blue separated represents dissociated, which means ionized. And the two together means that they are undissociated or together. So in a strong base, they are all unconnected. In a weak base, some of them are connected, or many of them are connected, but a few of them are not. Okay? Now, all of these substances, all the bases, just like on that previous slide, you know, all those numbers with dissociation values, bases have those as well. It's not important that you know those, just that the difference between a strong base and strong acids is they completely dissociate or completely ionize in solution. Weak acids and bases partially ionize. Only some of them fall apart, like this. Now, here are some common acids and bases. Probably the main ones that you need to know would be, I would say these three here. Hydrochloric acid is probably the most common acid, strong acid you've heard of. Some strong bases are probably sodium hydroxide and potassium hydroxide. Those are your probably most common ones. But I expect you to know these strong acids and bases. I expect if I said, hey, we're going to be using HCl, I expect you to go, oh, that's a strong acid. Okay? If I said something like, hey, we're going to be working with acetic acid today. Well, you're like, oh, I know it's an acid, but it's not one of these 4 acids, so that means it's not a strong acid. Now, the importance of that is knowing that the partial dissociation. Weak acids only partially dissociate. Strong acids completely dissociate. All of their particles are spread apart and not together. Okay? Strong bases, same way. I expect you to know these 4 strong bases. Sodium hydroxide, potassium hydroxide, barium hydroxide, and calcium hydroxide. You should know those as to be strong bases. Okay? Now, what we're also going to be looking at today is we're going to look at how to calculate the pH of solutions. And what that's also going to be tied to is what's called the autoionization of water. Now, water can actually react with itself. So what actually happens in this equation is we have 2 water molecules. And those 2 water molecules can actually react with each other. One of them will give a hydrogen to the other. So if this water right here gives a hydrogen to H2O, what that creates is H3O plus, and the one that lost the hydrogen becomes OH minus. So it becomes this. Now, there's a number that is associated with that, and we call it Kw. Kw stands for I would say, equilibrium constant, or it's a number that is associated with how much water does this. Now, the only reason you need to know this is because we're going to be getting ready to talk about something, or how we calculate pH and pOH, and also H plus and OH minus concentrations. So, when our H3O plus and our OH minus concentrations are equal to each other, we call that solution neutral. Or we would say it has a pH of 7. That might be the thing that you're most familiar with. Whenever our H3O plus concentration is greater than OH minus, we say that that's acidic. When H3O plus is less than the OH minus concentration, we'd say that that solution is basic. So here's a pH scale. You're probably used to seeing something like this. But basically anything below 7 we consider to be acidic. Anything above 7 we consider to be basic on the pH scale. Here's some common substances that we use in just household substances that have pHs. Typically, you've got like your sodas and your fruits and fruits, those are considered to be acidic. Then you've got a lot of your basic stuff like your cleaners and soaps that would be acidic. What's interesting is blood is actually slightly basic, right at about 7.4. So, how am I going to make this easier? You might be like, I am completely overwhelmed. So, here's what I want you to look at. This square can be used for any calculation from pH to pOH to OH minus and to H plus. So, let's say that I had my H plus concentration. And I'm going to put the screen up just so I can talk to you about it. Let's say that I knew my H plus concentration. And let's say that it was 0.52. So, and it would be written maybe something like this, 0.52 molar H plus. And they said, find the pH. Well, here's all that I do. Notice how if I go from H plus and I follow the arrow, there's an equation on that line. That equation is going to tell me what to do. And it says the pH is equal to the negative log of the H plus. Well, I have the H plus. So what I'm going to do is I'm going to take the negative log of it. So I do the negative log of 0.52. And that would give me my pH. Okay? Now, let's say that I wanted to go to pOH. Well, once I got this number, then I would use this equation. So Let me see. Let me calculate that real quick. And I'll actually use Google Calculator here to help you. Okay, so I wanted to take the negative log of 0.52. And I get 0.28. So that means that my pH would be 0.28. Then if I wanted to find my pOH, well, I would plug it into this equation. Well, I know my pH now. It's 0.28. So I do 0.28 plus my pOH equals 14. Well, I just subtract 0.28 from both sides. And 14 minus 0.28 is going to be 13.72. Which means my pOH is equal to 13.72. Then if I wanted to find my OH minus concentration, well, I know this answer now. It's 13.72. So then if I wanted to go from pOH up to OH minus, then I would use this equation right here because it's on that arrow. And it says the OH minus concentration is equal to 10 to the negative pOH. Well, I know my pOH. I just found it to be 13.7. So I would do 10 to the negative pOH, which would be negative 13.72. That's going to give me my OH minus. So I go to my Google calculator and I go, okay, I need to do, clear this, 10. Now you might be like, how do I put in an exponent? Well, you're going to actually go x to the y, which is this button right here. And I'm going to enter in negative 13.72. And I get 1.9 times 10 to the minus 14. Oops, let me switch back. What's that number? 1.9. There we go. That means that this answer right here is 1.9 times 10 to the minus 14 molar. And that would be my OH minus concentration. So that's how you can go from one thing to the other. Now you might be like, well, what if I just wanted to go across here? You can. But I don't like using this equation, and it's because of all of the scientific notation. You're welcome to try it. The only thing that I would make sure you do is put every number that you have that's in scientific notation in parentheses. If you don't, order of operations will kind of screw you up. Okay? So let's look at ones that are on your assignment. So, herein, whoops, let me erase this. So, this first row is completed for you. So let's start in number 2. So right now we know that the pH is 7. Well, if you look back at your chart, if you rewind, you'll see that in order, I guess let's look at it. In other words, we are here at pH. And that problem asked us to convert to all of the other units. In other words, it wants us to find the H+, it wants us to find the pOH, and it wants us to find the OH-. So we're going to do each of these calculations. We're going to go from pH to H+. Then we're going to come back and we're going to take that pH and we're going to go to pOH. Then we're going to go from pOH up to H+. Okay? So to go from pH to H+, I need to take 10 to the negative pH. So I'm going to do that first. So 10 to the negative pH, which is 7, gives us 1 times 10 to the minus 7. So I'd come down here, And for number 2, it's going to be 1 times 10 to the minus 7. Then I need to go over to pOH. Now remember, in order to go from pOH, or to pOH, excuse me, I'm going to start at my pH, and I'm going to go to pOH. Well, to do that, I'm going to do pH plus pOH. Well, I know that my pH was 7, so it's 7 plus pOH equals 14. Well, I subtract 7 from both sides, and that gives me that my pOH is equal to 7 as well. So, come back to my assignment. And my pOH is also 7. Then, I'm going to find my OH minus concentration. And in order to find my OH minus concentration, I need to go from pOH to OH minus. Well, my pOH was 7. So I'm going to do, to get my OH minus concentration, I'm going to do 10 to the negative pOH. So, I go to Google Calculator, and I go 10 x to the y, negative, my pOH was 7, and that gives me again 1 times 10 to the minus 7. So I come back to my assignment, and this is going to be 1 times 10 to the minus 7. But then I have to say, is it acidic or basic? Well, this actually is the very rare occurrence in which this substance is going to be neutral. And that's because this, our pH, a pH of 7, it would, in order for it to be acidic, it has to be below 7. In order for it to be basic, it has to be above. Because it is right on 7, we say that that substance is neutral. And that's how you do all of those problems. There's actually one more thing that I forgot to tell you guys. And that one thing is, I told you at the very beginning of the lesson that I would teach you how to estimate the H plus concentration or the OH minus concentrations of a solution. So here's how you do that. For instance, this problem here on the back side of your assignment says that you need to calculate the pH of the solutions below. Well, if you look at this solution here, okay, it doesn't give you an H plus concentration, it gives you HCl. Well, here's all you do to estimate the H plus concentration. If I were to put this in water, remember we said that strong acids dissociate, or they come apart. So what's going to happen is if I have a 0.01 molar solution of HCl, when I put this in water, these two things are going to break apart. And this is going to make, this substance is going to break apart, and it's going to make H plus and Cl minus. Now, whatever the molarity of our solution is, so our 0.01 molar HCl is actually going to be the same molarity as our H plus, which means I have 0.01 molar H plus, and I have 0.01 molar Cl minus. Now, I would do the exact same thing with my NaOH. If I have a 0.001 molar solution of NaOH, when I put this in water, it's going to split apart, and it's going to make Na plus and OH minus. What that means is whatever the molarity of my NaOH is also the molarity of my sodium and the molarity of my hydroxide ions. So that means that I would have a 0.001 molar solution of Na plus and a 0.001 molar solution of OH minus, which means in problem number 1, I'll use this number to find my pH, and in problem number 2, I'll use this OH minus concentration to find my pH. Now, if we look at these other problems, you'll notice that problem 6 and 7, they give you a percentage. So in number 6, it says you have a 2 molar HC2H3O2 solution. Now it says assume 5% dissociation. What that means is, remember, when this acetic acid breaks apart, this is actually a weak acid, which means when it falls apart, it's going to split apart into H plus and C2H3O2 minus, but only 5% of it is going to dissociate, which means I need to find what 5% of 2 molar is, and that will be how much H plus I get. So if I were to find what 5% of 2 molar is, it's actually, if I do 2.0 times 0.05, if you plug that into a calculator, you're going to get, anybody know? You're going to get 0.1, which means 0.1 is the molarity of my H plus. So in this problem here, I have 3 molar, so you do 0.3 times 10%, which would be 0.1, so 3 times 0.1 would give you how much H plus you get. And then you'll use those H plus concentrations to find your pH. Thanks for watching.